Well, hi everyone who has an Airstream and a hot water heater that does not have electric. This is the Hot Rod by Diamond Group, and that actually allows you to electrify your propane-only hot water heater. This apparently works with Suburban and Atwood heaters. Now, this kit comes with all you need to make this all work, including an adjustable thermostat, which also has an emergency cutoff switch as well. So what we did is we cut all shore power, disconnected the battery while we're doing all the electronic disconnections here. And just to speed this up, we went ahead and just took all the burner assembly off and really removed everything so we could actually work freely at the area. If you go quickly, this whole process outdoor process can go in an hour or so. But the trick is that they want you to put it on the back of the water heater, but you have no access. We only have accessibility to the side of our water heater, and perhaps a lot of Airstreams have the same issue. So with a lot of calling and talking and discuss this with the factory, as long as we get it on a flat surface, it should be able to transfer the heat fairly well from the metal tank to the thermostat. Now we also have very good access to the tank, and you can see that this is an exploded version, but if you look at the side of the tank, you can't really get to the back. So we decided to put it approximately here on the side of the tank, which is a bit rounded, but we still think it's the same rounding that it would have had if we were on the back of the tank. So for us, we're going to put it to the left side of the hatch tank access and kind of estimate it right about here. And we'll take out the thermostat and hold it up to see if we can actually guesstimate the size of it. Now we wanted to make sure that before we did any cutting, we could actually make sure we had some good flat mounting surface behind here. So verified that, and apparently this little thermostat has some tabs on the bottom side, which aren't really necessary, so we'll bend those up and out of the way in a second. But just mark it up approximately where it's going to go before we start cutting. So I spent a fair amount of time making sure this cut was going to be good. So it's one of those measure twice, cut once issues for sure, so that you keep a minimum amount of insulation cut away. Now also, this particular unit has some tabs on the bottom, which aren't necessary in our case, and to keep this nice and tight inside this narrow cutaway, we just bent those up and out of the way, keeping a nice rectangular shape. So now with the prep area open, we can actually imagine how this is going to mount, and as flat as possible to transfer the heat from the metal tank to the metal backing of the thermostat. And of course we want to make sure it's a good fit, so we took all the contaminants out of here so nothing would actually prevent the contact of the metal backing to the metal backing. Now with some isopropyl, able to move off any grease or any kind of contaminants further from the tank, because we really want this to be a very strong bond between thermostat, and this VHB tape is almost like screws. It becomes semi-permanent after 24 hours. So we went ahead and just got it all cleaned up, dried up, and then placed it and applied a lot of pressure to make sure it was firmly bonded to the metal tank area. So the manufacturer says it's good to let that bond for a good 24 hours before you apply heat to it. So we didn't have any rush for that, so we went ahead and did that. And also we're able to make a slice in the existing factory grommet that feeds through the copper propane tubing. So we went ahead and just put a little slice above that, ran that right through as to not put another physical hole through the Atwood frame there. So it nicely tucked in away, and we're able to put that grommet back in place everything's nice and snug. And the next thing we'll be doing is just sizing up the cable, approximately how much would backfeed into the cavity, and go from there. So with the weatherproof cap off, we can now imagine how this probe goes in and backfeed the cables and measure those up a bit just to see how they would lace up into the thermostat. And we'll go ahead and just look here where we had to get the original AC power from. We didn't have a local AC outlet near our water heater, so we had to come up into the kitchen cavity where the nearest one was right behind our microwave. And so we will eventually put a single GFI unit there with 2 openings. The factory is just a single opening, so temporarily we'll go ahead and put a little adapter and plug our water heater into that area versus going through our bed area, which is essentially right above the water heater. A little cleaner look. So we can figure that we'll be running our AC cable above the water heater up into the cavity above from inside, and that'll give us our AC area power to the location. Now, in our rig, we look at the one of the hidden cavities here. You can look through, and you can see right through the water pump area. You can look and really kind of catch a section of the hot water heater foam, and that's on that from the inside there. So we really can't work at it from behind. The side axis was really the way to go. So we laced up the wires, put some special tape on it, electrical tape, and we'll just tie it off here for security. And this is 120 volt wiring here, so you want to make sure that you don't leave it for snags or something to bump into it and cause it to rip loose. Now with the connections and the plastic protective cover place, you can see that there's a red reset button. That's in case the thermostat fails, and that unit will actually pop that reset button as a second safety factor. So we're going to go ahead and put a little bit of, we'll use some goop here on some of the metallic connections, which are not terribly hidden, so that nothing can actually get in there and touch them, or you can touch them with your wet hands. And still keep our adjustable thermostat settings relatively accessible if need be. So we decided to go ahead and put this junction cube, which will allow us to run a power strip. Now we decided to run a power strip to turn on and off the hot water heater, and the reason for this is we wanted an illuminated light and plus a hidden area where the unit would plug in on the far corner, so you can see the light on when it's lit up, but also it gives you some other electrical capabilities if you want to plug in, charge something in a protected area, like a laptop or a smartphone, without leaving it exposed to the open area. So with our power strip cord coming through, we're going to plug it into a power adapter. We're going to actually tape up and actually goop the cables so they're really hidden out of the way, not able to be touched. And then right here we can turn this on, indicating power strip on, and we're going to be plugging in our water heater to the far right behind the little corner there, so it's all nice and hidden. Now for the phase 2 of this project, we were told we really should be draining our hot water heater at least once or twice a year. We've had this for 5 years and never did it once. So, and we're the second owners, so there's definitely probably some contaminants inside here. So we got that little extender tank rinser wand. It's about $6 or $7 on Amazon, and got all this tooled up, ready to go. And so before we actually insert and install, we're going to blow our tank out, clean it all out as much as possible before we install our hot water probe, which the hot water probe conveniently installs in the same drain hole. So when you drain your tank, if you open up the pressure relief valve, you'll notice a lot more flow coming through, and that's going to drain just all the water in that hot water tank. And again, all power is off, all AC is off, no show power. Everything's disconnected for the most part while you're doing this. So part of this process is to kind of go in and spray this out a number of times until you get all the junk out of there. And you'll see a little later how much stuff actually comes out as you start agitating the water and blowing with this wand. There's little chunks of minerals, things that are kind of coming out. The more and more you flush, you'll see kind of like a cloudy, milky substance coming out of there, which all this white material here is really just the built-up sediment that came out of the tank. The other brown sediment was already there from just in the carrier. But with some help from the wand model, we'll continue on. Don't spray. So another better recommended technique to continue cleaning the tank is to use a 50-50 solution of vinegar and water and let that sit in the tank for a number of hours, sometimes 5 to 24 hours, depending on how bad you think it is. We're doing a cheap shot way of just dumping some vinegar inside the tank, and that's going to settle in the bottom of the tank where most of all our sediment was, apparently. So we'll let this sit for a while. Just plug this up and come back a little while later. So as you can see here, it'll sit and hopefully break up some more of this mineral deposits, at least in our area in Southern California. That's what we got out of our area here. So fast forward a number of hours later, come back in, drain this again, and flush it some more, which some more material came out, probably double the amount we had before. The vinegar ate away some contaminants on the plug as well, so we know it's working. So now that's done, we're going to use some Lasco pipe sealer, the kind that works on LP, high temperature, and takes the place of standard Teflon threads. We wanted to make sure it just had a really good bond. So we put that on the reducing bushing for our Atwood, and with a different socket set, kind of give it a good snug. You don't want to go too tight. You could possibly damage the inside of the tank if you do so. Now the reducer's in, we're going to go ahead and do the same on the probe, heat probe, and gently just slide that in and spin that together. Because this is plugging into the drain hole, you want to make sure you don't put it too tight, because you will have to disassemble these things in the near future to drain your tank again. So we're just going to give it some good snug turns, put the waterproof cap back on. You can see it's going through the bushing into the storage cavity area, and now we can reassemble the rest of the burner kit with the same material. Want to make sure that's not leaking any propane. And tightening back up all of the 5 or 6 bolts for the spark generator and the other area, but you do want to make sure you have 2 sets of pliers on tightening up this area where the gas joins to the burner kit. Reestablish connections on all the electronics, plug back the sparker probe, and with all that back together, we can start filling the fresh water back up from city water, and we want to make sure we're getting water back into the tank here. We open up the pressure relief valve to make sure that the water fill is coming directly in and going to fill that water tank. We do not want to fire up any hot water probe without that being full of water. That's a very important factor per the manufacturer. Now the water's coming out, we know the water's at least topped out and dumping out the top of the tank, indicating it's full. Now that's all done, we are now ready to test the standard water heater in the conventional way using the propane. That looks like it came back alive just perfectly. So the burner and all the adjustments, all that's working well. Now we're going to come up here and plug in the hot water heater for the first time. And with power restored to the rig, shore power restored to the rig, we're going to fire that up. And that's going to energize the hot water probe now. We put a watt meter to see just how much this would pull. And we'll come back and take a look at that in a little while. So at 5:53, we started the hot water probe. And again, just looking at all the sediment, this is all the stuff that was in there probably having a problem. Now, an hour later, we're getting some hot water heat and we're getting up to about 107 degrees, so it looks like things are working. About another 15 minutes, it went to 110. And seeing how much power was taken, you might be able to see this, but it's 0.75 kilowatt, I believe it was, and so we'll figure out how much. That was an hour and 48 minutes of use. And according to the manufacturer, it's a 400 watt probe.
This is 1.5 hours.
So it draws maybe about 4 amps max when it's heating up. So it looks like about 0.75 kilowatt, and at that time, water started getting much hotter, and even about 2 hours later, we got up to 134 degrees, which is something we've never seen out of our sink. So this thing is really starting to work well and doing a good job. Anyways, thanks for watching. Hope you enjoyed it, and we give this a 2 thumbs up. Appreciate watching.